Hey everyone, and welcome to the series Machine Learning Made Simple. In this video series, I teach you the fundamentals of the most popular, most widely used machine learning algorithms. In today's video, we are talking about k-nearest neighbors, which again is one of the most popular classifiers in all of machine learning, so it's a great place to start your machine learning journey. In today's video, you're going to understand the fundamentals of the KNN algorithm, how it works, both from a mathematical and intuitive standpoint. We'll talk about strengths, weaknesses, and then most importantly, at the end of the video, I'm going to show you how to actually implement the KNN algorithm in just a few lines of code using the R programming language. So we have got a lot to learn. It is going to be a little bit longer video. I will put timestamps so you can jump ahead. But with that being said, let's go ahead, let's jump right in and start learning. Hey everyone, and welcome back. I am the part-time economist, and in today's video we are talking about KNN. In the first part of the video, I'm explaining how it works, why it works, everything like that. If you are just here to see how it works with R programming language, feel free to skip ahead. But before we start talking about KNN, we need to know what even is KNN, also known as k-nearest neighbors. And for that, we need a definition. Now, I'm going to share with you two different definitions. The first is very formal. It's very professional, but it's a little bit confusing. And then the second definition, I think, makes a little bit more intuitive sense. So the official definition from IBM is that the k-nearest neighbors algorithm is a non-parametric supervised learning classifier which uses proximity to make classifications or predictions about the grouping of an individual data point. It is one of the popular and simplest classification and regression classifiers used in machine learning today. So obviously an important definition, lots of big words. All of those big words are important and we'll talk about them, but just kind of for getting started, I like to keep it simple. When it comes to KNN, just think of it this way. Birds of a feather flock together. When we use KNN, all that we're doing is we have an unknown data point and we're saying, look, I have this unknown data point. Maybe it is a tumor and I don't know if it's cancerous or benign. Maybe it's a student and I'm predicting if they're going to pass or fail a class. What I do is I take that unknown example and I say, do I have similar examples? So can I find students that studied a similar number of hours and missed a similar number of classes? Did they pass or fail? Well, if all of the students that studied the same number of hours as my unknown student passed the class, it's a pretty good guess that my student will pass also. Here's what that looks like graphically. So we've got a simple XY coordinate plane of vehicles. We have the speed of the vehicle and then their miles per gallon. How fuel efficient are they? In the bottom left, we have vehicles that are slow and low miles per gallon, the red X's. Now, that could be something like a bus, a garbage truck. We'll just call them utility vehicles. On the far right, we have high miles per gallon, but also kind of slow. These are your just everyday cars, your sedans that people use to get from one place to another. Then we have the green triangles, things that are fast, but also low miles per gallon. These are your supercars, okay? And then I ask you, I say, if you had to pick this white question mark, which type of vehicle do you think it is? And you would say, well, it has pretty low MPG, pretty low speed. It's probably some kind of a utility vehicle. So that is all we're doing with KNN. We're trying to classify, usually, a unknown data point based on what other data points are most similar to it. And it's great to have an intuitive understanding, but we also want to look at the mathematics. So let's go with another example. Let's suppose I'm a professor and I want to predict, is this student going to pass or fail my course? And I don't know because I've not given the final exam. But let's suppose I do know. This student studies 2 hours per week and they've missed 3 courses throughout the semester. What I want to do is go back and look at similar examples of students. And wouldn't you believe it, I have some great examples. Last semester, I had a student that only studied 1 hour per week and missed 3 lectures. They failed my course. And I have a student that studied 5 hours per week and only missed 1 course. So what I want to do is I want to say, which of these is most like the unknown student? The way that we do that is by calculating the distance. And this is just a simple XY graph, so we can calculate a simple Euclidean algebraic distance, right? So that's how we're going to do it. Keep in mind there are other distance metrics. If we're doing 5 variables, right, we use a different distance metric. If we are comparing the similarity of strings, right, text, again, there's a different distance metric. You need to know about that, but don't worry about it. Just think about it as a simple line between 2 points. So what's the difference, or the distance, we can say it either way, between missing 3 lectures and 3 lectures? Well, obviously 0. What's the difference between studying 2 hours per week and 1 hour per week? Well, it is 1. So the total distance between the student that failed and the unknown student is 1 unit. Now let's compare to the student that passed. Well, for that, we need to take 5 hours of study minus 2, so that's a difference of 3, and then 1 class missed versus 3, that's a difference of 2. So if we work through all of the math, the total distance or difference between the unknown student and the failed student was 1 unit. The difference between the passing student and the unknown student was 3.6. So just looking at this, if this is the only data we have, we say, look, this unknown student is most similar to the student that failed, so we are going to predict that they fail as well. In reality, that's not a great way of making predictions because we're going off just a single data point, and there can be some problems with that. So look at this example, the unknown student in yellow, the red student that failed. That student in red, they studied a lot, but they still failed. They could have been an outlier, or maybe they lied about how much they studied. So the cool thing about KNN, and this is where the K comes from, is we can use a different number of nearest neighbors. So not just the most similar data point, let's go with the most 3 similar, or the most 5, or 7, or 9, whatever the case may be. What we can do is we can use more classifiers. So what we're going to do is we're going to go through all the data points we have. We're going to do the calculations for each data point. And then we're going to say, okay, the closest 3 data points, the first one is only 1 unit away, the second one is 2, then the third one is 2.2. Now, out of those 3 closest data points, 2 of those 3 students passed the exam, so 2/3, we predict that our student passes the exam as well. So that's how it works. Now, even with this, there's a couple things that maybe should be going through our head. Number 1, what's the optimal number of nearest neighbors to use? Should we just go with the number 1 nearest neighbor, the closest, most similar data point? Or should we go with more nearest neighbors, right? And get more of kind of an average, right? Believe it or not, there's pros and cons to both, which we will talk about later. And then if we are using multiple nearest neighbors, you can see that this red X is closer than the 2 blue smiley faces. So should we really give each one an equal vote in this 2/3 rule, or should we give more priority, even among these 3 nearest neighbors, to the nearest neighbor that is closest to our unknown data point? Those are things that I want you to think about. But for right now, we're going to take a break from the theory. We're actually going to go ahead and see how this looks in the R programming language. Then we'll come back and finish wrapping up with some of these other theoretical things that are important. Alrighty, so now we are in R Studio. We're going to see how KNN actually works, but before we get started, I do want to mention a couple things. Number 1, this is not an introduction to R programming course. It's about learning KNN. So some of the stuff I'm going to skip over because it's background knowledge. You don't need to know how to do it. It's just kind of the setup. I will try and put the code online so you can follow along if you want to. Number 2, there are lots of different ways of doing the same thing in R. There's 10 plus packages that do the KNN algorithm. If you use another one, you like it, feel free to use it. I'm just trying to show you one that I thought was the simplest for this video. So that being said, the first thing we're going to do is, if we don't have them, we are going to install both the tidyverse and the neighbor packages. and then pull them into our workspace using the library command. This, what I'm doing here, you don't need to worry about it. I'm just creating a fictitious data set about students, whether they pass, whether they fail, how many hours they study, and the number of lectures that they miss. Again, don't worry about what I'm doing. If you're doing an assignment, a project, they're going to give you a data set. So there's that. All right, continuing. Now, here's where we need to start paying attention, because when it comes to KNN, there's a couple things that we need. Number one, we need unknown data points, right? Students that we don't know whether they passed or failed. So we need an unknown data set and we need a known data set, because remember, with KNN, we are saying this unknown data point, what is it similar to? So KNN needs to know, this is what a student that fails the course, this is what they look like in terms of hours studied and lectures missed. This is what a student that passes the course looks like. So we need a data set of known data and unknown data. So we're going to assign both of those to variables. Again, this is something you don't really need to worry too much about. If you're doing this for an assignment, for a project, you will be given different data sets, right? This will be your training data set. This is your test. You just need to bring them into R as two separate variables. So we have the known examples, we have the unknown student, and if we look at both of those, we can see the known examples have the outcome, classes skipped, hours studied. Obviously, the unknown student is not going to have because we don't know. Okay, perfect. Now what we need to do is we need to tell KNN the outcomes, right? So what we need to do is give it the labels of that training set. So what we're going to do is we're going to go into the known examples, and we're going to select whatever our Y variable is. So here, it's course outcome. If you were doing something such as, again, tumors, and you're trying to figure out, are they benign or are they cancerous? Your Y variable might be something like diagnosis. So all you're doing is whatever this column name is, you're putting it after the $sign, okay? And as factor just tells R that we are not trying to treat this as a character variable. Just put as factor in there to keep it simple. Okay, so those are the known labels. And when we look at that, fail, 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 pass, 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 right? Those are the outcomes. Okay, perfect. Now, let's take a look at our data. Again, this isn't something you need to know how to do. It's just background information to help you understand better. This blue data point, the unknown student, they are right between two other students that failed. So just intuitively looking at this data, we're going to predict that they fail as well. It's helpful, but it's not the answer we're looking for. So we actually want to run the KNN algorithm. The way we do that is by assigning a variable name. Again, that can be whatever you want. You can call it KNN model, my model, prediction model. Doesn't matter. Then we type KNN, which is the name of the function. We have to use this training underscore set. That is telling KNN these are the known examples. We then pass in whatever we called our known examples, okay? Test set is the unknown, and you might say, why are you using training set? Why are you using testing set? Well, if we go to the help page for this specific algorithm, what it does is it tells us how we have to pass these things in. So it needs a training set, a test set, all of those things. The categorical target, that is going to be the course outcome. Where is that coming from? Well, it is coming from, again, this Y column. So whatever you named your Y column here, that's what it needs to be named here. And then lastly, comparison metric. For now, just put Euclidean. Just put Euclidean for now. I'll explain it later. So let's go ahead and run that. We have the KNN model. Where are our predictions? Well, they're inside the model, because remember, KNN is a lazy learner. So we don't have to do a train and predict step. It's doing that as part of the model. The way that we access them, again, we're going to create a variable to hold those predictions. We're going to go to the KNN model, and then this is just something you have to remember or copy and paste. Within the model, we have the test scores and the categorical target. We're going to enter that. And now it shows us the prediction that the student failed. Okay, cool. That's not very helpful. What we want to do now is we want to go back and assign to each unknown student their predicted outcome. How do we do that? what we do, we go to the unknown student, that's the unknown, and then we're going to create a new column using this $sign, and the new name is going to be prediction, and we fill that column with the predictions we made in KNN. And what you'll see now when we go to unknown students, we have classes skipped, hours studied, and their prediction, right? Obviously, if we were doing 15, 20 data points, it's the same process. It's just going to fill each corresponding to the student. Okay, so that's the basic KNN model. I do want to talk about a couple caveats. Normally when you're doing KNN, because it is a distance-based algorithm, we want to make sure we have standardized distances. So if we're doing something such as hours studied, right? Students are going to study from like 1 to 10 hours per week, right? Then let's suppose for whatever reason we wanted to include a variable of the number of miles that the college is from their hometown, right? Well, some students could be 5 miles away, some could be from across the globe, 10,000 miles. So that difference of 99,995 miles is going to completely overrule the amount of studying that was done. So we typically want to standardize our values. In this example, both things were on a 1 to 10 scale, so we didn't need to do that. Keep in mind, you do need to standardize. Some KNN packages will do this for you, so just check in the help page to see whether yours does that or whether you need to do it yourself. Now, a couple other options, things that I told you, hey, don't worry about this, we'll come back to it later. When we are going through here, we have the ability to manually specify certain hyperparameters. So we can say k equals 3, and we're telling it choose the outcome versus the nearest 3 neighbors, or 5 neighbors, or 7 neighbors. Another thing that we can do when it comes to this comparison measure, we can change that to others as well. So this specific package, I don't think it supports some of the more advanced ones, but if we needed it, we could specify it. So that's the basics of how to run a KNN algorithm using R. Let's hop back to the theoretical portion of the video. Okay, perfect. Now that you have seen how KNN works in the R programming language, let's talk about some additional considerations. KNN is a relatively simple algorithm. It's easy to learn, easy to interpret, and there's not a ton of hyperparameters, but there are 2 that we need to talk about. And we alluded to this previously. How many nearest neighbors do we use to make our decision? And how should we assign weight to these nearest neighbors? Well, as with everything in machine learning, there's trade-offs. There's not necessarily a right answer. Let me give you an example here. When it comes to choosing the optimal number of nearest neighbors, if we go with the most similar example, on the one hand, we're going with the most similar example. However, that is going to introduce a lot of variance into our data set. Maybe we're making a prediction based off one outlier, right? You can see here, this student in yellow, the closest data point is someone that passed the class, but literally everyone else that studied for a similar amount of time and missed a similar number of classes failed. So that's the problem with using too small of a K. On the flip side, if we use the entire data set of K, then we're essentially just predicting based on the categorical average, right? So there's a little bit of thought that goes into it. My advice would be, unless you have a good reason, I would just use the defaults that come with R or whatever statistical package you're using. The defaults work really well in a lot of scenarios. Number 2, how much weight do we assign to the proximity of the known data points, right? So in this example, the nearest 5 neighbors, 4 of them are passing, 1 of them is failing, but the one that failed is like identical to that unknown value. So here's the problem. If we give too much weight to that proximity of the data point, we're essentially turning K5, K7 nearest neighbors into K equals 1 nearest neighbor if we're giving it too much of a vote. If we give it too little of a vote, then we're saying that an example that is virtually identical to the unknown should have as much weight as something that could be considerably different. So again, there's a bias variance trade-off there. Again, my advice would be, if you're watching this as a beginner, just use the defaults that come with your package. We do need to talk about strengths, weaknesses of KNN. So strengths. It is easy to implement and explain. you can tell someone that's not a statistics major, hey, things that are similar are more likely to be similar, right? And in all of these different situations that we have data on, it's very similar to this unknown, so therefore I think this unknown is going to be XYZ, right? We can explain that to a decision maker, a CEO, a boss, a manager, someone that doesn't have a ton of statistics training, which can't be said for other things like neural networks, for example. It's adaptive. There's no need to retrain the model because we're not really creating a model anyway. And there's few hyperparameters. There are some weaknesses though. One of the main weaknesses with KNN is that it is a lazy learner. Now, what this means is that we're not really creating an equation. If you come from a economics or a traditional statistics background, you've probably done linear regression. And linear regression, we come up with a function and we say, someone's predicted salary is 30,000 plus 1.5 times the number of years of school, right? It's a formula. We just plug values in and we get a new prediction. With KNN, we don't really create a formula. What we do, we throw all the data points into the computer memory, and then whenever we get an unknown example, we go through all of those data points, trying to find the closest data points. So it can be very memory intensive, and it can be slow. It can also struggle with some other things that you don't really need to worry about. You just need to know that it's a lazy learner. Those things do exist, but for all its strengths, for all its weaknesses, the key thing to remember is that KNN is one of the most widely used for a reason. It works very well in a variety of circumstances. A couple other things that I do want to point out. KNN is a non-parametric algorithm. This means that we don't have to assume a normal distribution like we do with a t-test or linear regression, something like that. That makes it very powerful. Also, KNN is typically used as a classification algorithm. Is something a cat, a dog, or a salamander, right? We can use KNN for regression, for predicting a numerical value. It's not as commonly done, but it is possible. Additional info, things that you do need to keep in mind. When it comes to KNN, a lot of the algorithms in R, you just plug in your data, you use the defaults. However, as you get more advanced, as you get into it, you'll hear people talking about different distance metrics, different kernels. All of those things are important. And then the last takeaway, I do want to remind you, we did talk about it earlier. We want to make sure that our data is either scaled or that the package we're using scales our data for us. So I know this was a little bit of a longer video, but I really wanted to cover the basics and not leave anything out. So I hope you found the video useful. I do appreciate you watching, and I'll see you next time.